In this section, we want to talk about properties that allow us to work with and simplify expressions that contain exponents and radicals. To start off, we'll look at two rules of exponents, the product and quotient rules. In example 1, we want to simplify the expression a cubed, or a to the third power, times a squared. To think about doing this, what we want to do is consider that a to the third power literally just means take a times a times a, so multiply it by itself 3 times, and then a squared means a times a. So what we end up with when we sort of expand that out or write that out as individual factors, we end up with the expression a to the 5th, since we have a multiplied by itself 5 times, which we could rewrite specifically as a to the 3 plus 2 power. So expanding that out, we see that we have a times itself 5 times. That is a to the 5th power, which we can think of as a raised to the 3 plus 2. And we can generalize that into a pattern, which is anytime we have a to the m power times a to the n power, we can combine those two by simply adding those two exponents together. So that will always become a to the m plus n power. Looking at example 2, where we have a to the 5th over a to the 3rd, this is the same thing as a times itself 5 times, divided by a times itself 3 times. Any value divided by itself is just going to cancel out to 1. So we'll have 1, 2, 3 pairs of a's that cancel out. And what we're left with then is just the 2 a's in the numerator, which would be a squared. And again, we can write that in a very particular way. We could write that as a to the 5th minus 3, which would be 2. So we can generalize this pattern anytime we have a to the mth power over a to the nth power. We can combine those into a single exponential statement by writing it as a to the m minus n power. Those exponents will always combine or reduce in that same pattern.